Afternoon, everyone. We had some excellent session just now on cryptocurrency. Now we'll try to move back to the AI topic one more time. So this time we'll talk about. Uh, we did discuss a lot of things, even during Joe's introductory session about AI models, etc. So we wanted to bring in a couple of thoughts around what do you think about this AI from a life cycle standpoint, AI model life cycle standpoint? So to discuss some of the topics here, I have three panelists. Aaron from Zions Bank, Alan Eads from Hancock Whitney, and Cole from Atlantic Union. So, with uh, with that, I will first let the panelists introduce themselves. Aaron, would you like to go first?
Sure. Yeah, I'm Aaron Benson. I'm the Director of Model Risk Management at Zions Bank. I've been here at Zions for a little over a decade.
Cole?
Good afternoon, everyone. Kole Kostic. I'm ERM Director at Atlantic Union Bank for credit, model risk, and financial risk management, real estate valuations. I've been in model risk for a while. I appreciate this opportunity. I look forward to your questions.
Thank you, Cole. Alan?
I'm Alan Eads. I'm Senior Vice President, Model Risk Management and Data Governance at Hancock Whitney Bank.
Thank you. So, Aaron, I think I will start with you. A lot of industry discussions and topics that are being talked about these days revolve around what is an AI model? How might model identification change from traditional methods? What are some of the challenges and recommendations that you may have? Or suddenly we also see that there's this possibility of thousands of models or AI models that become part of the inventory. How do you manage these challenges? So I'll throw these topics at you, and please speak on those.
Sure. Yeah. So to start, I think I would want to address uh, kind of a question that embedded in your question, which is what is an AI model? How is that different from models or AI or any other buzzwords we might throw at it? If you look at the textbook definition of AI, that's a kind of an all-encompassing framework that includes deep learning and machine learning and statistical methods. There are traditional econometric forecasting models. Those are all AI. But I don't think that when we're talking about AI in a session like this today, that's what anybody's talking about. If you look kind of in the history of or a more recent history of machine learning or learning, there's kind of a difference in model types, kind of based on different methods or models of generating these models. The statistician Leo Breiman, who was at Berkeley, defined these two different models of developing models. I wish you'd use a different word than model, but these are models developed in either following what he called a data model or an algorithmic model. And the data models are those that assume that there's some sort of data generating process that's a function that we can define and we can use statistical methods to kind of recover that function and then use that to make forecasts. And then he defined this algorithmic model or method or approach for modeling, which takes the process by which data is generated as a black box. And we're going to try and maybe approximate that, but we don't really care what that black box looks like. And as model risk management at banks has evolved over time, we've moved from strictly thinking about mitigating risk of kind of these data models and moving into mitigating risk of the algorithmic type models, where the algorithmic processes are black boxes of the type that are often defined as machine learning models or deep learning models, where they have things like non-interpretable parameters, which affects how we approach our validation of those models and the risk management of the models, where from the data model developed models. Those would have estimated parameters that we could review for intuitiveness and make sure that the signs are correct and the magnitudes are correct. But now with these more black box models, the parameters are non-interpretable. And as we move down the river of this kind of algorithmic method for doing predictions, we start adding more elements like inaccessible training data, like data sets that are so large that we would never have resources at a bank to investigate that data, let alone have even access to it, or non-replicable methodology, where sometimes if you're given some kind of black box model, like an XGBoost or something, you can replicate the objective of that model using something that's more traditional or more transparent. But a generative AI model or an LLM has a methodology and an objective that's wholly out of reach for a model risk management group at a bank to try and replicate. And so I think when we talk about AI models, we're referring to these inaccessible algorithmic methods and approaches that are essentially have components of it that make it completely impossible for us to replicate, not just replicate the model, but even replicate using a simpler method. We're never going to be able to create some sort of challenge or benchmark to ChatGPT, for example, in our group. And so the challenges that we talk about in AI modeling, I think, stem from this component of the AI models that we're reviewing. But I do like to point out that some of those challenges are of a type that we have overcome in the past already in model risk management. The kind of opacity or non-replicability of some of these models are similar to those kinds of challenges that arrive when we have vendor models, where vendors are unwilling or unable to provide us with transparency into the methodology or the data. So we already have ways of dealing with the risk when we've removed kind of these traditional elements of model risk management from the individual models. So when we talk about identification of these AI models, I think one thing that has helped us, and I think I've seen has helped other banks, is to inventory or consider the inventory, the identification by use case of the model itself rather than by individual instance. So we have, I think we see many vendors, maybe all vendors, feel the need to include some sort of LLM element within their tool that they're providing to individual banks. And so it's possible that a bank could have 100 different tools that have some sort of document summarization or document Q&A element embedded within that are all from the same foundational LLM. And as an identification exercise, it might be more helpful to identify that use case of a tool that allows an analyst who's a subject matter expert to review a document quickly and to subject that document to Q&A processes. And that could be considered a model by itself. And then there's individual instances where that model or that use case is embedded in different tools. Another thing that I think is important to help understand or help guide identification of AI tools is to recognize that there's maybe more similarities between these modern Gen AI tools and software systems than there are similarities between these AI models and our traditional models. So there's lots of different business units using lots of different vendor and internal solutions when we talk about technology or software. And that's really similar to how AI models are starting to enter into banks. And so it's possible that a model risk group could partner with the technology operations group that already has good experience in inventorying hundreds or thousands of different tools across the bank and maybe include like a field or a different type of tool that triggers for AI models. And so then the model risk group could partner with the technology operations group to either pull from their inventory of software assets that are AI models, or merge the two. There's lots of different possibilities there. And then a final point that I think is important to understand is that the vast majority of these AI models are incredibly low risk, and I think Kole is going to talk more about that risk assessment. But if these are very low risk use cases, they require less information in the inventory and in the identification process as well. I think the identification and inventory process should probably be risk-based in accordance with the lower risk that is probably presented by these tools.
Thank you, Aaron. So that takes me naturally to Kole one point, which is, now that we have identified these models, how do you even risk rate them, right? So looks like inherently they are complex. Maybe they are all high risk models. Are they all tier one models? What are some of the challenges that you may encounter as you build your program?
Thanks, Raman. Yes, after the models have been identified, the next step is usually to try to understand the risks, and the best way to do that is through risk assessment. So I guess the main question for me was, can I leverage the existing risk assessment methodology that I use for the traditional, let's call them like that, models for AI models? And the answer is kind of yes or no. So for traditional risk assessment, usually what I saw pretty much is a relatively common approach. We have some risk factors, and then we assign high, moderate, low, high, moderate, low, and so maybe 3 or 5 tier risk assessment scale. We assign some weights. We get the risk score based on the threshold. It's a high, moderate, low model risk. I'm talking about inherent model risk. Maybe some advanced risk assessment tools, maybe they split the factors into impact factors and then likelihood factors. We weight all those factors. We have maybe 2 different weighted scores. We multiply them. Usually that's how it's done. We get some inherent risk score, and then based again on some thresholds we assign whether it's high, moderate, low, or if we use 5-tier scale. We have 2 additional risk ratings. So overall, that methodology, I think, is still applicable for AI models. But many of the factors that we use currently for our traditional risk assessment, and which are, I think, SR 11-7 is to some extent prescriptive regarding them, are still applicable for AI, for risk assessment of AI models. So we have financial impact, economic impact, the complexity, data, aggregate model risk. So all of these factors, I think, they're still applicable to risk assessment of AI models. But then there are some factors, and we heard a few speakers talking about them before, that are kind of intrinsic to artificial intelligence models. So one of them is, for example, explainability. Can we really easily understand how model design, theory, processing, all those things, outputs has been used? Is the output easy to interpret, and so on and so forth? And someone can argue that, yes, we covered that kind of previously if we had like a vendor factor, because many vendors previously, they wouldn't provide their secret recipes to us. But again, for AI models, I think there is like additional level of in explainability, because for these vendor models that we use traditionally for, let's say, 10, 20 years, they've been around the block, so we can kind of rely, because they're like industry standard models. Now with AI, we have many of these models, they're like brand new. So we cannot really understand how they work, and then we don't have like that industry test saying, yes, this is a good tool to use. Then another factor that usually maybe people don't think too often, and again, somebody else brought it earlier today, I think it was John, is how much we rely on the output of these models. And for traditional models, we kind of would have override analysis where we see how often we override the model output and how much we rely on this. But for AI models, we have like a really interesting, to me, it's a new novel risk where we kind of over-rely. We have over-reliance. I think John talked about it in the first session a lot, where because they just sound so convincing and they're like experts, and people just believe to what we hear, especially they talk to you now. We don't even have to see, we can listen to all these models, right? So they're so convincing, and then we're kind of removing the human judgment. People don't try anymore maybe to judge. And I'm just wondering what's going to happen in a few years from now. So I think that's another factor that can be used for risk assessment. Then another one, these are again like bias, making bias, unfair, discriminatory decisions. That can be another factor. And there was again a presentation about climate risks, so we can think about environmental factor. We know that gas plants are used for producing energy. There's a big CO2 emission from using these large models, and how that affects our PDs and LGDs. I guess we had a presentation earlier today, so that can also have impact on the bank. So that would be maybe some of the factors that existing traditional risk assessment methodology doesn't have, that probably it can be augmented by including those factors to perform risk assessment of AI models. When it comes to risk assessment, maybe another important thing is like how many risk assessments should we have? So we have one for traditional, maybe expand this one for AI models, but then we have, as Aaron was talking, we have classical AI, we have traditional AI, we have generative AI. Do we need to have a separate methodology for generative AI? So that's another thing to think about. And again, somebody talked about this previously. We need to make that distinction that AI risk and AI model risk are two different things. That kind of AI model risk is a subset of the AI risk, because we have all those things that I guess we talk about that those risks before, like cybersecurity, privacy, data risks, data breaches, all those things. So it's very important to have a good risk assessment system, not only for AI models, but also for the AI risk, especially when we have stakeholders from throughout the company, let's say as a part of an AI working group. Because if we have a good AI risk assessment methodology, that kind of empowers all the stakeholders to ask the right question, to understand the risk, and then once we understand the risk, then we can proceed with mitigation actions and see what we need to validate, which to prioritize validation, utilization of the tools, and so on and so forth. Also, there's one more thing when I talk about risk assessment. So this was primarily regarding inherent model risk. But then we all have to report, I would think, in model risk world to I guess management and board regarding the residual model risk. And so then you have probably some kind of like control environment, you have control design effectiveness, control operating effectiveness, and then you have some kind of methodology regarding that. But with AI, there is one new, I would think also novel risk that covers the sustainability of these controls. If you think about traditional models, we have, let's say, model controls, source controls. They're kind of stable throughout. Throughout the time, they don't change much. But with AI models, how sustainable those controls are, how often we have changes, how often are we going to come to maybe a place where the AI tools will rewrite the code itself. There are all kinds of possibilities there. So that can prompt us maybe to do assessment of the residual risk more often, because maybe we'll have to check on the controls more often. The whole risk assessment process, do we need to do, traditionally I would do personally once a year And those risk assessments, they wouldn't change like material year over year. But for AI, do we need to do risk assessments every 6 months, every 3 months, just because there are so many changes involved in the whole process?
Interesting call. Thank you. So this naturally the two important points that you raised: the dynamic nature of the so-called AI models, or what I would call sometimes as models with AI components in them. So the natural question here is validation, which touched upon this previously as well. Alan, I know you are leading some of these discussions at the bank and grappling with these issues of how do you even what are some of the challenges in these type of model validations? Can you use some of the traditional techniques? Can AI be part of validation of AI models? We know that documentation will be sparse on these type
Right.
of techniques. So just want to get your thoughts and see how you are shaping these discussions at the bank.
Yeah. One point I want to make on all of it is we go through validations. When we talk through with our AI working group, which is a group that any tool or model or a solution that has any AI componentry has to go through that, and it gets grilled and all before it gets approved for use. But one really good distinction that excuse me, I think Jonathan made very early on was the difference between an AI model and a machine learning model, because AI, the term just gets thrown around a lot, and and then the validation of each, they're different in terms of the way we would validate and really the ease of validation on them. But one of the things I've seen more and more from a use case standpoint is, and it's something we're focusing on, is that interdependence between maybe a traditional model or what's deemed a machine learning model and a true AI tool or model that's used with it. And that, in terms of the ability to validate all of that properly, as you mentioned, the documentation challenges are much greater because the explainability piece has to be there. It has to be, as I press to our model owners and all, is you're going to have to get to the level of, and it may be if you developed it internally or if you're working with the vendor, but it needs to be a document that you could hand to someone and they could understand it as much as possible without being involved and without working for the bank. So that's one of the foundations that when I've talked to regulators, is having that explainability in there. And the next thing you get into is really the mechanics and the data and all. That's a huge challenge of where does the data come from? What is the data quality intact? How does that affect the validation? How does it affect the performance and everything? So what I think we'll end up with at the end of the day is much greater focus on model interdependency between traditional models, machine learning models, and AI solutions, and a much tighter agreement between model risk management and data governance. I manage both sides here at Hancock Whitney, and we're focusing on that data lineage piece and that data quality piece to be as dynamic as possible because of all of the model inputs and outputs that come and go and how they work together, because all of that's needed for these validations. You need to be able to then look at, well, how am I going to manage tuning a model versus change-based validation that's necessary versus a full scope validation. And a lot of that goes back to what we've talked about on the risk ratings of things. If you've got a relatively low risk AI model, for example, a chat GPT type thing, or something that's just referencing a bunch of policies that are loaded in, and it's a QA type solution, that's that's not a ton. That's vastly different than if you were using a machine learning model that was iterating every night based on transaction activities and other things, that was making a decision on whether or not to authorize use of a line of credit the next day or make a marketing offer to somebody the next day. And so while that machine learning model might be a little more like the traditional sense of how you would develop a logistic regression model or a decision tree type model, you just have to account for the tuning and the variability and the data iterating every night. But if you couple that with an AI solution that comes up with something that's customer facing, so AI interprets the decision and other factors and says, well, I'm going to send Raman this text, I'm going to send Kole this text, and I'm going to send Aaron this text. That gets into that system validation where you kind of look at that interdependency, and you have to be able to show that this model made the right decision and this model sent the right text, and account for all of that variability in it. And that's where the real pain points come from, is because that requires either AI tools to help you with those validations, something that's in there really monitoring that drift, monitoring all of those things, or it takes resources. And that's where you change from a model owner that might be a little more, I don't say detached from the process, but maybe they're monitoring, performance monitoring only once a quarter. Well, now they're going to be having to look at that a lot more, weekly, monthly, daily in cases like that. And that's all got to be part of the validation because of the model performance plan and everything else. And I know, this is kind of it's hard to get your arms around all of it. And it's if you think about when you get into the question of what happens when thousands or hundreds of models exist in the bank, even if it's just segmentation within things, then that's something we press on, is it's going to take resources. It's going to take either financial resources of providing tools, or it's going to take people staring at these models a lot more than maybe they do today. And that's something we have to be very transparent with management when you get into the ROI on these as well. In terms of the impact on validations and all, I think it's going to require a combination of that human and the AI tools to help with these going forward. And that's certainly something we've looked at. The monitoring plans, I think that I know in talking with regulators, that's a big focus, is having those model monitoring plans in place. And I think that's going to be a real trick for any AI models. It might be as simple as when we brought in Copilot, for example, we have a standard set of simple questions just to ask and kind of go up in degree of that. Well, that's, you do that periodically just to make sure that it's not going to return the wrong answer all of a sudden of, who's president and things like that. But you also need to press it when we get into, have that functionality in place. So when we get into more detailed things that'll come. If we're meeting a year from now, I'll be very shocked if we don't see banks using those machine learning decision models and AI customer facing solutions tied to it, to where you don't have a very elaborate continuous validation process going on. So that's where I think we're heading, and at least that's what we're planning for, is to set those expectations and to kind of go down through our checklists and make sure we can account for, or try to account for, everything along that path, if that makes sense. Because I think somebody, I forget if it was Jonathan or somebody early on, brought up the fact that there hasn't been a whole lot of new guidance from the Fed or the regulators on this. So it's a little bit of carve your own path, but be able to defend it. And that's where you get into kind of the hard work of developing these validation plans.
Thanks, Alan. I think this also is very highly related to what Joydeep and Tom were talking about during the AI model governance session. So it looks like in a nutshell, we do have many challenges ahead of us in terms of the MRM frameworks, whether it's identification, risk assessment, or validation. So I think we have to have a few more discussions along these lines. We do have a question from Pratyusha on how to treat these third-party validators using AI tools.